Going to record dreaded 102 here. 102 has a yucky looking left and a yucky looking right. We're going to leave the right. We're going to play around with the left here. Cosine squared theta tangent cubed theta is equal to tangent theta minus sine theta cosine theta. Now, I'm going to, what's your ideas?
I tried putting in the sine for the cosine.
You're going to eventually. But for right now, let's wait with that. Let's leave cosine squared alone. Change tangent into what? Sine cubed theta over cosine cubed theta. This is called trig definition. Now there's 4 trig definitions that you should know about. One is tangent theta. What's that equal to? Sine theta. And notice you don't just say sine over cosine. I know it's a shortcut, but it's like saying square root when you mean square root of like 5. You've got to say what it's of. So sine of theta, cosine of theta. What's cotangent? Cosine theta over sine theta, very good. And the secant is 1 over something. Cosecant is 1 over something. Which one is 1 over cosine? Secant is 1 over cosine of theta. And then cosecant will be 1 over the sine of theta. Great. These are called the trig definitions. And you don't have to write them out. You just have to say they're one of the trig definitions. I want you to write that. And these are called the Pythagorean identities. You'll need to write that out too. Okay, so why did I do this? Change tangent into sine cubed over cosine cubed. Why did I do that? Sam, what do you think?
Then you can put the cosine squared of theta on the top of the fraction, then cancel out cosines.
You got it. You're going to lose 2 of each of these, leaving sine cubed theta over cosine theta. That's way better, isn't it? Now, you mentioned, Greta, about Pythagorean identity. I think we're going to do that. I'm going to split sine cubed into sine squared times sine, and then these are multiplied. I'm going to keep this over cosine. And what's sine theta over cosine theta? What is that? That's tangent. Yep. So this is going to be trig definition again. Tangent theta times sine squared. Ooh, now we're getting close. I want to change this sine squared. What's sine squared equal to? Here's my sine squared. What's it equal to? 1 minus cosine squared. So I have tangent theta, 1 minus cosine squared theta. And this is a Pythagorean identity. You multiply these out and finish it. See what happens. So we'll have tangent theta times 1 minus tangent theta times cosine squared theta. Tangent theta minus sine over cosine theta times cosine squared theta. That's a trig definition. And then all we have to do is what? What's left? Lose one of the cosines. And so that will result in tangent theta minus sine theta times cosine theta, which is equal to what we were looking for. Sine theta, cosine theta, left-hand side equals right-hand side, and we are done. That is Pythagorean theorems and trig definitions used several times. And there might be a swifter way of, maybe I did something a little more than I had to, switching back and forth there. But I like how that one ends up. We'll do the first one here. Cosecant theta. 1 plus cotangent squared is cosecant squared theta. That's a trig identity. Okay, and so then one of those is going to cancel out, leaving 1 over, thank you, cosecant of theta. And then cosecant is 1 over what? What's that? 1 over sine. So you'll have 1 over sine theta. And that's a trig definition. Oh, go back to this one. I lied. This is Pythagorean identity. 1 plus cotangent squared equals cosecant squared. This cosecant's 1 over sine. Well, what's 1 over sine algebraically? 1 over sine is sine of theta. Great. You got it. And so left-hand side equals right-hand side. This one, definitely do the right side of the equation. You're going to have 1 plus tangent squared is secant squared theta to the 4th times secant squared theta. That is a Pythagorean identity. Write that down. And then secant squared to the 4th is secant to the 8th times secant squared. And what's secant to the 8th times secant squared? Secant to the what? 10th. And that's what we wanted. Left-hand side equals right-hand side. Is that good? You doing all right with those? And so that's proving with identities, knowing your trig definitions and your Pythagorean identities. Now we're going to go to day 2. And with day 2, you're going to have 4 problems, 86, 104, and 120 and 124. On number, and then there's another one for you to do after that, but that's not a proof. Go to number 124. Excuse me, 120. Go to number 120. And with 120, I'm curious, raise your hand if you'd work the left side. Raise your hand if you'd work the right side. How many said left side? How many say right side? Okay. I'm not sure, but I'm pretty sure the left is going to be the way to go. So why don't you start with the left? So for this left side, what's your first move? Eleanor, what did you do first?
Well, I don't know if it's right, but I did trig definition.
Yeah, I like it.
1 over sine minus 1 over cosine of theta over sine theta.
Cosine of theta over sine theta. That's perfect. And that would be your trig definitions. 2 of them, actually. 2 for 1 there. So some people would have trouble with this, but not you. What's 8 over 3 minus 4 over 3? What is that? It's 8 minus 4 over 3, right? Or 4 over 3. 8 minus. So you can combine these with one denominator. Okay? So then you're going to do the same thing here. You're going to go 1 over 1 minus cosine theta over sine theta. Is that part all right? Then this here is your numerator. This 1 minus cosine below the big line is the denominator. That means sine is the what? Numerator. So you're going to get sine theta over 1 minus cosine theta. And I bet this is where you got stuck. And that's okay. I would expect it. So what we're going to do is a crazy step here, kind of out of thin air. And what you would do is, what if you had 1 over 1 plus the square root of 2? You ever seen anything like that? Do you remember how to get rid of that square root of 2? What do you multiply top and bottom by, Abby? Square root of 2 would be interesting, but it wouldn't get you what you want. There you go. Not 1 plus, 1 minus. Why is that? Well, this is what we call the conjugate, because in the numerator you get 1 minus square root of 2. In the bottom you get 1 times 1. Then the square root of 2 minus square root of 2 would cancel out the middle term, and then you'd square that 2, getting rid of that square root in the denominator. We're going to get rid of that cosine in the denominator, sort of, by multiplying by the conjugate. So I'm going to multiply 1 cosine theta, 1 cosine theta, and what do we do here? If this is minus, this will be plus. This is multiplying by the conjugate. You don't even have to write it down. It's just a technique. And so when we multiply this out, I'm going to get 1 plus cosine theta times sine theta all over 1 times 1 minus cosine squared theta. What? That didn't help. Somebody tell me why that helped, because it did. Yeah. So say that again. You have 1 minus cosine squared. Why is that good? Do the conjugate again. That would be interesting, but you don't even need to do that. 1 minus cosine squared is our friend. Yes, Pythagorean identity. If you subtract this, you're going to get 1 minus cosine squared equal to what? Sine squared. So you have 1 plus cosine theta times sine theta all over sine squared theta. And now what happens? Boy, this is a lot of work. Yep, now you lose one of the signs. And you'll get 1 plus cosine theta all over sine theta. Well, that was a lot of work. That was a lot of work. But now we have 1 over sine theta plus cosine theta over sine theta. And what's that equal to? I'll let you finish it. And that's lesson for today, dealing with identities, fractions, and conjugate.